Alright, so Levi and Noah. So our problem is a construction worker pulls a 5-meter plank up the side of a building under construction by means of a rope tied to one end of the plank. Assume the opposite end of the plank follows a path perpendicular to the wall of the building, and the workers pull the rope at a rate of 0.15 meters per second. How fast is the end of the plank sliding along the ground when it is 2.5 meters from the wall of the building? So our variables, L, length of the plank is 5 meters, distance is what we're solving for, and Y is the vertical distance from the ground to the point where the plank touches the wall, 2.5 meters. Here's our diagram of the problem. We have the wall, we have the plank, and we have the distance we're solving for. X gets smaller, Y gets bigger.
Yeah, as the plank goes up.
Yep.
So now I'll explain the math part. We use the Pythagorean theorem. X squared plus y squared equals L squared. We know L is 5. Square that. That's going to be 25. X squared plus y squared equals 25. Then we used implicit differentiation to do x squared plus y squared equals d over dx 25. We use the power rule down here to make 2x dx over dt plus 2y dx over dt. And then we use the constant rule to have 0. And then we divided both sides by 2 to make x dx over dt plus y dx over dt. And we divided x and y from both to make it dx over dt, which is what we're solving for, equal to negative y over x dy dt. So now that we have the equation, we're going to go ahead and go down here and add Pythagorean theorem again, but this time we'll be adding in the x, which is 2.5, as set up here. So 2.5 squared plus y squared equals 25. If you solve for y, you get y squared equals 18.75, which if you root it, 4.33. Now we can solve for dy over dt, or we can plug in for dy over dt to solve for dx over dt, which will be negative 4.33 over 2.5, and then times the 0.15 meters per second, which in total will give you the negative 2.6, which we rounded, but to be exact, negative 0.2598 meters per second. Some tips and tricks we used were the power rule, the constant rule, and our use of implicit differentiation to solve for dx over dt. It's our project.
Yep.